Hi guys, Miss McGann, and we are talking about adding and subtracting with scientific notation. We're going to go through little tips and tricks and things to watch out for, and let's get started. So we have 3.2 times 10 to the fourth minus 1.7 times 10 to the fourth. So we are going to, with adding and subtracting, you always want to make sure that the exponents are the same. So 10 to the fourth, check. And then what you would do is you just normally subtract like you normally would. So we're going to keep that the same. Just bring it on down. 3.2 minus 1.7. I guess I can borrow. We can go old school on this one. So do 5, 1.5. Awesome. So we have 1.5 times 10 to the fourth. Is that written in scientific notation? Do you guys remember? Yeah, so we have to look to make sure that the first number is between 1 and 10, and then it's times 10 to some power. So 1.5 is between 1 and 10, so that looks good to go to me. All right, let's move on down. Here's another subtraction problem. So we have 5.8 times 10 to the sixth minus 4.1 times 10 to the fifth. Are exponents the same? Oh, no, they're not. We have 10 to the sixth and then 10 to the fifth. So the trick is to get those exponents to be the same, so we can't just subtract like normal. We're going to have to look at our numbers, and you could write this all out. You could write it as it would be if you move the decimal all of the spaces. So it would be 5,800,000. You could write that and then try to match out the numbers that way. So 410000. What I like to do is if we're going to move our decimal, so I always try to move to go to the higher exponent. So 5 and 6 would be higher. So I want to try to make this one become a 6. And what I can do is I can move my decimal one more to the left, and then I can raise my exponent. If I was to move my decimal to the right, I would decrease my exponent. So when you move the decimal to the left, raise it. When you move it to the right, you're going to decrease it. So these are just those numbers written out. All right, so I'll just erase that, just clarity purposes. So now we have 5.8. This is an 8. Sometimes my 8's so weird. Minus 0.41. So we have 10 to the 6, 10 to the 6, because I moved my decimal over in the second number. This 8 just looks really goofy. So if I get my trusty calculator, or you can do it by hand, you do 5.8 minus 0.41, we get 539. 5.39. And we're going to keep our same exponent value, power of 10. We have 5.39 times 10 to the 6th for this answer. And so I just made sure that I kept that same decimal version. This first number is between 1 and 10, so we should be good to go, and it's times 10 to some power. All right, let's move over here to our addition problem. So we have 2.7 times 10 to the third plus 6.9 times 10 to the second. And are our exponents the same? They're not, so we're going to need to change it. Like I said, I always want to go to the higher one. So it's between 2 and 3. 3 is the higher one. So I'm going to try to move that 2 to a 3. I would just need to increase by 1. And like I said, I would move my decimal 1 to the left, and then I can increase my exponent up 1. Okay? 2.7 times 10 to the third plus 0.69. So now it is 2.7 plus 0.69. You don't really have to rewrite it. I like to, because I like to line up my decimals, so I see what I'm working with. And then it's going to be times 10 to the third power, because that's what we had it. Awesome. So we have 2.7 plus 0.69 equals 3.39. So 3.39 times 10 to the third is my answer. Okay, and then our final problem, we're adding, want to check our exponents. They're not the same. Oh, there's actually a gap of 2. So this one's 4, that one's 6. I'm going to try to go to the higher number. So I want to move this up 2. So I'm going to move my decimal over 2. All right, that's what I'm going to do there. So that way I can make this times 10 to the 6th. Awesome. So if I was adding 4.8 plus 0.72, we add it all together, and it's going to be 4.872. I'm just being silly. 4.872 if we added all of those together. So if we have 4.872 times 10 to the 6th, is the first number between 1 and 10? It is. But let's say, what if it wasn't? What if it was like 48? Let's try that again. What if it was 48.72 times 10 to the 6th? If you got a number that first number is not between 1 and 10, you would just try to, keeping the digits in the same order, move the decimal over. So it'd be 4.872. And then if you move it one more over, you're going to have to add 1 to the exponents, right? So you do times 10 to the 7. So that way, when we multiply it all out, it becomes the same number. So, any questions about adding and subtracting with scientific notation, please let me know. But I look forward to helping you guys soon.